July 20, 1976. Martian Milestone. Viking 1 became the first United States spacecraft to successfully land on the surface of Mars, marking a defining moment in the history of American space exploration. Operated by the National Aeronautics and Space Administration, NASA, the Viking 1 mission represented a major scientific and engineering achievement during the height of the Cold War era's space competition. The event occurred exactly 7 years after the Apollo 11 lunar landing, reinforcing the date as a symbol of American progress in planetary exploration. Viking 1 was launched from Cape Canaveral, Florida, on August 20, 1975. The spacecraft consisted of two primary components, an orbiter and a lander. After traveling over 480 million kilometers, Viking 1 entered Mars orbit on June 19, 1976. The original landing date was set for July 4, 1976, coinciding with the bicentennial of the United States. However, NASA delayed the landing due to concerns about surface hazards identified in initial imaging. Scientists eventually selected a safer landing site in Chryse Planitia, a relatively flat region in the northern equatorial zone of Mars. At 11:53 a.m. Eastern Daylight Time on July 20, 1976, the lander separated from the orbiter and descended through the Martian atmosphere using a heat shield, parachutes, and retro-rockets. It touched down gently on the surface, sending a radio signal back to Earth confirming a successful landing. Within minutes, Viking 1 transmitted the first clear photographs from the surface of Mars, revealing a rocky terrain under a pinkish sky. These images were the first ever taken from the Martian surface by a U.S. mission, offering humanity an unprecedented view of another planet. The scientific instruments on board the lander included cameras, a meteorology package, a seismometer, and a suite of experiments designed to search for signs of life. The most controversial of these was the labeled release experiment, which introduced radioactive nutrients to Martian soil samples to detect possible metabolic activity. The results were inconclusive. Although the experiment produced data that some interpreted as possible evidence of microbial activity, the consensus among scientists was that the signals were more likely the result of chemical reactions rather than biological processes. Viking 1 also measured atmospheric conditions, including temperature, pressure, wind speeds, and composition. It confirmed that the Martian atmosphere was composed mostly of carbon dioxide, with surface temperatures well below freezing and no evidence of liquid water. The data helped scientists understand the planet's harsh environmental conditions and guided future mission planning. In orbit, the Viking 1 orbiter surveyed the planet's surface for over 4 years. It produced thousands of high-resolution images that mapped approximately 97% of Mars at a resolution of 150 to 300 meters per pixel. These maps were crucial in understanding Martian geology, including volcanic features such as Olympus Mons and evidence of ancient riverbeds and floodplains, suggesting that Mars may have once had a warmer, wetter climate. The Viking program consisted of 2 identical missions, Viking 1 and Viking 2. Viking 2 successfully landed on September 3, 1976. Together, the twin missions represented the most ambitious and technologically complex planetary program undertaken by the United States at that time. Viking 1 operated for more than 6 years, sending its final transmission on November 11, 1982. The success of Viking 1 demonstrated the United States' capability to conduct long-distance planetary operations with precision and scientific rigor. It provided a model for later missions, including Pathfinder, Spirit, Opportunity, Curiosity, and Perseverance. Although the Viking missions did not confirm the existence of life on Mars, they set a scientific foundation for ongoing exploration and stimulated interest in Mars as a candidate for habitability and possible human missions in the future. July 20, 1976, remains a landmark in space history. Viking 1's landing represented more than a technological feat. It was a milestone that expanded human understanding of the solar system and our place within it. The data and images it returned are still used today in comparative planetology and mission planning. Its legacy lives on in every subsequent Mars mission that builds on the knowledge first gained through that historic descent onto the Martian surface. For enthusiasts of historical ephemera, visit history-collectors.com to find collectibles that might complement your collection. You can own a piece of history.